In this video, we will understand what is a function. To understand this, let us look at an example. Suppose we made a circle with a radius. We have made a second circle smaller than this, and a third circle that is smaller than the rest of the two. On looking carefully, we came to know that as the radius decreased, the area of the circle also decreased. This means the area of the circle depends on its radius. And in mathematics, whenever one quantity depends on another quantity, we say that the former quantity is a function of the latter. We know that the area of the circle is equal to pi r square. Because area depends on the radius, so we say the area is the function of the radius. Let's understand this with another real-life example. How much time will this moving car take to cover a distance? This will depend on the speed of the car and the distance it has to cover. So the time taken is also a function of speed and distance. That's why we have a speed, time, distance formula. Now come back to our same problem. Let's find the area of these three circles. Suppose the radius of the first circle is 1 meter. And with the help of this formula, we can calculate its area. The area of the first circle came to pi meter square. Suppose the radius of the second circle is 0.75 meter. And its area came approximately 0.5625 pi meter square. And the radius of the third circle is 0.5 meter. And its area is 0.25 pi meter square. 1 meter, 0.75 meter, and 0.50 meter is the radius of these three circles. This is our input. So the set of all possible input values for the radius is called the domain of the function. And what is the output? Area of the circle, right? So the set of all output values of the area is the range of the function. In mathematics, to denote that y is a function of x, we write y equals f of x. We read as y equals f of x. In this notation, x is called the independent variable, represents an input value from the domain of f. And y, the dependent variable, represents the corresponding output value of f of x in the range of f. In the case of the circle, the area is the function of radius. We write a equals f of r. Here r is an independent variable. And a is a dependent variable. Since circles cannot have negative radii, so the domain of the circular area function is 0 to infinity, means all non-negative numbers. Neither the area of the circle can be negative, hence the range is 0 to infinity. Why do we have so much interest in drawing graphs of a function? Because a picture is worth 1,000 words. This is certainly true in mathematics. The behavior of the function is best described by drawing its graph. Suppose we were given a function that is y equals x square. The graph of function consists of points in a Cartesian plane whose coordinates, x, y, are pairs of input-output values of f. We calculate those pairs. First of all, we put -2 in place of x. The square of -2 is 4, right? This is how we got our first pair, -2, 4. Let's calculate another pair. This time we place a -1 in place of x. Square or -1 is 1, right? We got our second pair, -1, 1. Similarly, we can find other pairs also, and we can make a table of these pairs. Now plot the points on the graph one by one and join them with a smooth curve. And both its domain and range will be from -infinity to +infinity. Now we see another example. Y equals the square root of x. Make the table of x, y pairs and plot the points on graph and join them with a smooth curve. But its range and domain are different from the previous one. Here we can only square root of positive x values, otherwise, the output will be a complex number. Hence, both the domain and the range are from 0 to infinite. Functions can be combined in a variety of ways to make new functions. Suppose we have f as a function of x equals x square and g as another function of x equals to x. Let's combine these two functions and create new functions. There are 5 ways to do it algebraically by adding, subtracting, multiplying, and dividing functions, and a 5th special case. We will see that later. First of all, we add both these functions. In this way, we create a new function f plus g of x. What happened with this? Let us understand it with the help of a graph. You can see the graph of x square and x. Now we see the graph of f plus g. Look at this carefully. When we add two functions, then their output also gets added. Observe the height of graph of f plus g at any point x is the sum of the heights of graphs of f and g at any point. Similarly, look at the graph of f minus g. Again, observe that the height of graph of fg at any point x is the difference of the height of graphs of f and g. Similarly for f into g. And f divided by g. G of x should not be equal to 0 because then it will be undefined. And it is undefined on the origin. And last special case, multiply the function with a constant. And c as any real number. C f of x equals c into f. Suppose we have function x square and c equals 2. Let's multiply this constant with function. You can see the graph of 2 into x square. The height of the new function at any point x is 2 times the height of x square. We will see the composite function and the trigonometry function in the next video. Thank you.